Okay, we're moving on to unit 0.2. This is the function families. Okay, first we're going to start off with the linear function family. A linear function is any function that takes the form y equals mx plus b. Where m and b are real numbers. Now what's important with that real number part is they could also be 0. So you could get equations that look like this. Here's a couple examples. You can get y equals 2x plus 1. mx plus b. We're all good. Okay. But if m was equal to 0, 0 times x, that'd just be 0. 0 times anything is always 0. So you could get a function that looks like y equals 2. Okay. And you could also get a function that looks like y equals 4x. Okay. In this case, b is 0, and all you have is a slope. So this first function is a function that looks like this. Whoops, let me line it up a little bit better. Okay. So it starts at positive 1 and goes up 2 over 1, and it's a straight line. Y equals 2, on the other hand, is always going to be at 2. There's the x-axis, there's the y-axis. This is always going to be 2 no matter what, because it doesn't matter what number you plug in for x, there is no x, it's always going to be 2. And then you've got a function like that. Here's the x-axis, here's our y-axis. And this one just gets pretty steep. So notice, as you move from left to right, you will not have a maximum or a minimum. Okay? Technically, this doesn't have a maximum or a minimum either, because it's just one number. It's a constant function. And this is also going to have no maximum or a minimum. Okay? So linear functions have no max or min. Now, as you can tell, they are all lines. They only have vertical symmetry if it's called a constant function. This one's called a constant linear function. Okay. So only has symmetry if it's a constant function. And next, this function goes up. This function is a constant function. This is also an increasing function. So a graph is a decreasing function if you have y equals negative 3x plus 2. Or y equals negative x plus 1. Or y equals negative x minus 2. So this would be an example of this graph. There's x, there's y. Here's an example of another graph. Negative x plus 1. and here's negative x minus 2. Okay. So the function is increasing when the number in front of x is positive. It is constant when there is no x, and it is decreasing when the m value is negative. So that's your linear function. Got a whole bunch of examples. Okay, next we are going to talk about quadratic functions. Quadratic functions take the form y equals ax squared plus bx plus c, where a, b, and c are real numbers. So for example, and just like the other problem, you can have 0, you can have negatives, you can have positives, you can have fractions, decimals. As long as it has an x squared, you're good. And it is a quadratic function. So here's one example, y equals x squared. That's the mama function, the main function that everything else is shifted from. You also have y equals 2x squared, y equals negative x squared plus 2, or y equals negative x squared minus 2x plus 1. Okay. So this function, this is the parent function. We also have this one. Which is a little bit skinnier. And there's also this function. And this last one over here. So I bet you're wondering how I got these graphs, how I'm able to know what they look like. The specifics right now aren't important. We're going to get to that a little bit later. I just want you guys to be able to figure out what the graph looks like and how you can tell certain characteristics about it. Okay. So a couple of things that we should see. If the a value is positive, that means the number in front of x squared is positive, it goes from decreasing to increasing. It's decreasing all the way until we get to this point, and then it starts increasing again. Whereas if the a value is negative, it's increasing at first, and then it gets to its highest point, and then it decreases. Okay. So if a is positive, it decreases, then increases. If a is negative, it's the other way around. another thing we got to talk about. When a is positive, it both had these points here that were called minimum values. So if a is positive, it has a minimum. And if a is negative, it has a maximum. As you can tell, all of these graphs are curves and none of them are straight lines. And every single one of these graphs, all quadratic graphs, have vertical symmetry. Every single one of them. Okay, the next kind of function is a linear absolute value function. Okay, and that looks like y equals the absolute value of x, y equals the negative absolute value of x, or y equals the negative absolute value of x plus 2. Really what the linear absolute value function looks like is y equals a parentheses, sorry, not parentheses, absolute value brackets, x plus b inside plus c. And again, a, b, and c are real numbers that could be 0. So this first function is the V-shaped graph that we've seen before. For this function, because there's a negative in front of the absolute value signs, the V-shape goes down. And this one looks real similar, just with a slight shift. It heads downwards. Yeah. So it follows a lot of the same patterns as before. If the a value, the number in front of the parentheses, or in this case the brackets, if that number is positive, we are decreasing and then increasing. If it's negative, increasing, then decreasing. Okay, so it's still the same. And again, if it's positive, okay, this is also a minimum value. This is a maximum. And this would also be a maximum. Okay. These are made up of straight lines, no curves, but they also have vertical symmetry as well. Okay. The biggest giveaway that you know it's an absolute value function is the fact that these are absolute value bars. These are the only kinds of functions that will have absolute value bars in them. Okay. The way you know that these functions are quadratic is they have an exponent of 2. Okay. Every single one of these has an exponent of 2. Next, we have linear piecewise functions. And this one looks pretty weird. It's a little wonky. But this looks like f of x equals x. when x is less than 0. And we'll say this is equal to 2 when x is greater than 0. So it has the stipulation. It's saying that when I'm talking about the left side of the y-axis, the negative x-axis, I want to be this function. And then a little bit later, after a while, I want to be this function. Okay. It's kind of like, you know, how we wear our clothes. When it's, you know, before 6 o'clock in the morning, you know, I'm feeling a little cold, I want to wear a sweater. And then after 6 o'clock, I mean, especially when we're in Fresno, it's going to get a little hotter, so maybe I don't want to wear my sweater anymore. Maybe I want to do something different. Maybe I want to wear a tank top. I don't know. Okay. So this is just an example of one, but just note it's two different functions that happen at two separate times. Okay. So in this case, this graph looks like this. Again, two different pieces of it. Could also look like f of x equals x when x is less than 0, x squared when x is greater than 0, so on one side, I've got myself a straight line, a linear graph. And on the other side, I got a quadratic graph. Okay. I guess technically that wouldn't be a linear piecewise function since this part's not linear, but just know that it's spread up into different pieces. Okay. Again, these guys don't really have maxes or minimums. So no max, no mins. It could if you set it up. I mean, it really just depends on the type of function. Increasing, decreasing, again, just depends on the function that's in there. Okay. Mostly linear, otherwise it wouldn't be a linear piecewise function, so I messed up a little bit. And symmetric, and again, sometimes it depends. Depends on what kind of functions you have that are piecewise. Okay. So, two more. We've got this thing called an exponential function. An exponential function takes on the form f of x equals a times b to the x power. And again, a and b are real numbers. So some examples of this would be y equals 2 to the x, y equals 1/2 to the x, y equals negative 2 to the x. Okay, so 2 to the x will look like this. Actually, let me make this clear a little bit. Whoops. Ignore that. I'll have another example later. So 2 to the x will look something like this. It's a curved graph. It looks similar to quadratic, but it doesn't loop up on the other side. This one, however, comes down and evens out. And this one starts even and then just tanks. So these are exponential functions. They do not have a maximum or a minimum. This goes on forever, getting bigger as we go to the right. It goes on forever, getting smaller as we go to the left. Okay. But I mean, it kind of depends. It takes a perfect mixture to make things increasing or decreasing. So for example, this is a case where b is greater than 1. b has the x attached to it. See, this is b, it has the x attached to it. b has the x attached to it. Okay. If b is greater than 1, it is increasing. If b is less than 1, but positive, meaning it can't be 0, it can't be negative, that is where it's decreasing. If there is a negative value in front, like this one, 2 to the x was an increasing function, but negative 2 to the x is a decreasing function. If it's negative in front, this switches. Negative changes everything. And last but not least, we have non-functions. Okay. Non-functions. Okay. A non-function is anything that doesn't pass the vertical line test. So for example, okay, if you take this function here, actually it's not a function, but if you were to look at this graph, you think, okay, it's a sideways U-shaped graph, it's a function, it's like a quadratic, right? Wrong. If you were to take a vertical line, a straight edge, and you were to put that on the graph, if it touches in more than two places, if it touches in more than one place, so for example, we cross here and we cross here, it fails the vertical line test and it is not a function. Okay. So if the graph is crossed more than once, with a vertical line, it is not a function. So this is where it could have horizontal symmetry, maxes and minimums, doesn't really look like it, but there's a lot of things in the world that are non-functions. But just for the sake of this class, if it fails the vertical line test, it is not a function, a non-function. Okay, thank you very much.